Okay, so now I want to return to this part of what we were talking about before. I want to go back and talk more about lines and equations of lines. And we had here y is equal to mx plus k, that's the gradient intercept form of the line. And importantly there, m gives us the gradient of the line and k gives us the y-intercept. And so if I have two lines, I can tell immediately if they are in point gradient or gradient intercept form whether those lines are parallel, because parallel lines have the same gradient. So in other words, if I have two lines and I write them in gradient intercept form, both lines will have the same value of m. So parallel lines have the same gradient. So for example, the question says 2x plus 5y minus 7 and 4x plus 10y plus 20. Are those lines parallel? Well, really all I have to do is write them in gradient intercept form and see if they've got the same gradient. So let's do that. So here for part A, I can say the first line is 2x plus 5y minus 7 is equal to 0. So therefore 5y is equal to minus 2x plus 7. And so y is equal to minus 2/5 x plus 7 on 5. So there is that equation in gradient intercept form. And so therefore I know the gradient of this line. So that tells me that m, I might call it m1, is minus 2/5. That's the gradient of that particular line. Do the same for the second line, and I have 4x plus 10y plus 20 is equal to 0. Therefore 10y is equal to minus 4x minus 20. So y is equal to minus 4/10 x minus 20 on 10, which I can write as minus 2/5 x minus 2. Importantly there, I can read the gradient, it is minus 2/5, the same as the first one. So here m2 is also minus 2/5. And I can say since they have the same gradient, implies they are parallel. So those two lines are indeed parallel. Let me now have a look at B. So in part B, it's the same first line. So here I've got 2x plus 5y minus 7 is equal to 0. So that rearranges to y is equal to minus 2/5 x. Can't read it. Minus 2/5 x plus 7 on 5. So m1 is equal to minus 2/5. The other one is 4x plus 10y Now this time it's minus 14 is equal to 0. So if I rearrange that, I get 10y is equal to minus 4x plus 14. So y will be minus 2/5 x plus 7 on 5. So obviously this thing has the same slope. These two lines are parallel, but more than that, these equations are exactly the same. And so what this is saying is that equation actually represent the same line. So I could say these not only are they parallel, but they're coincident, might be another way of saying that. So here, the two equations represent the same line. And as I say, maths beak might say i.e., oops, already got that there. They are parallel and coincident. Might be another way of saying the same thing. And equations that represent the same line, if you look at them, will always be a constant multiple of each other. So for example, if I go back to this equation, if I multiplied everything by 2, here I would get 4x plus 10y minus 14 is equal to 0. So in that case, it was plus 20, then, so therefore it's not the same line, whereas in this case where it's minus 14, it is the same line. So that is a constant multiple of that, or the other way round. Okay? And that will always be the case. They will only represent the same line if one is a constant multiple of the other.
It doesn't have to be a factor, it just has to be a multiple.
Say again?
It doesn't have to be a factor, or it just has to be a multiple.
Well, a factor is a multiple, because I could have said, look, I've multiplied that by a half.
Yeah.
Okay? It doesn't have to be a whole number.
Yeah.
I mean, I could multiply by the square root of 2 in here as well. So I could have 2 root 2 plus 5 root 2y minus 7 root 2 equal to 0, and that would still be the same line. Yeah, yeah. Just a constant multiple. Yeah. So let's make use of the fact that we know about parallel lines now. It says find the equation of the line passing through a given point and whose gradient doesn't actually give us a value, but it tells us it's parallel to this line. So our strategy will be the line we're after, the line we want, will be. Now look, I'll do it one way and then I'll do it another way a bit later on. So I'm going to say, look, the line that I want is y is equal to mx plus k. My job is to find the appropriate value of m and the appropriate value of k. Now, over here, I know that this line is parallel to x. I know it's parallel to x minus 4y plus 11 equal to 0. So it's going to have the same slope as this one. So the m will be given if I can rewrite this in gradient intercept form. So let me write that as 4y is equal to x plus 11. So y is equal to 1/4 x plus 11 on 4. And so the slope of this line is m is equal to 1/4. So I know this line has slope 1/4. So therefore I know that this line also has slope 1/4. Now m is equal to 1/4, and I can put that from there. So all I have to do now is find k, and to find k I use the fact that the 0.5 minus 3 lies on the line. So I can say since 5 minus 3 lies on the line, I have when x is 5, y is minus 3. So y is minus 3 when x is 5. So here that's 5 quarters. So I've got minus 3 minus 5 on 4. Minus 3 is minus 12 on 4, so I'll add another 5, so that'll be minus 17 on 4 sitting there. So that says k is equal to minus 17 on 4. And my line is, therefore the line that I'm after is y is equal to 1/4 x minus 17 on 4. And just check. When I put x equal to 5, that's 5 on 4. 5 on 4 minus 17 on 4 is minus 12 on 4, which is indeed minus 3. So it's got the right point lying on it. Now, just out of interest's sake here, I could write this in general form. So if I multiply through by 4 and get everything onto the left-hand side, I will have x minus 4y minus 17 is equal to 0. There it is in general form. Look at this one. X minus 4y minus 17 equals 0, and this line up here, that's x minus 4y plus 11 is equal to 0. So the coefficients of the x and the y are the same in those two equations, and that's not surprising because if I were to rearrange that and make y the subject, I'd end up with 1/4 x. Likewise, if I rearrange this and I'll end up with 1/4 x. So the only difference between these two lines is always going to be just the constant at the finish. So if you're a brave person, you can actually say, okay, the line that I want is going to be x minus 4y plus something is equal to 0. Substitute in 5 minus 3 and you're done. If you wanted to do that, I wouldn't be upset. Okay. So that's parallel lines. There's also a nice result for lines that are at right angles to each other, that are perpendicular. And it says if two lines are perpendicular, then their slopes multiply together to give minus 1. And that comes in handy as well. So perpendicular lines, their slopes multiply together to give minus 1. So here it says, is x minus 2y plus 6 and 2x plus y equal to plus 12 equal to 0? Are those lines at right angles? Are they perpendicular? Well, let's check. I've got x minus 2y plus 6 is equal to 0. To work out the slope, probably the easiest way is to put it into gradient intercept form. So this will say 2y is equal to x plus 6. So y is equal to 1/2 x plus 3. So the slope of this line is the coefficient of the x, so m1 is 1/2 in that case. Let's go to the other line. And I have 2x plus y plus 12 is equal to 0. That says y is equal to minus 2x minus 12. There it is in gradient intercept form. So therefore the slope of this one, m2 is minus 2. let me multiply those two together. And I can say here, M1 times M2, that's a half times minus 2, that's equal to minus 1. So these lines are indeed at right angles. So they represent the graphs of perpendicular lines. Okay, so it says, determine the gradient of any line, it doesn't say which particular line, any line that is perpendicular to this one. So sitting here, we know the gradient of this line. Here, M1 is 2/3. So therefore I know the slope of a perpendicular. So any line that is perpendicular to that one will have slope 2/3 times m, and I'll call it 2, has to be equal to minus 1. The slopes have to multiply. And so M2 has slope minus 3 on 2. And of course there's a whole family of lines that are perpendicular to this one here. So here's the graph of 2/3 x minus 7, and I guess it doesn't go something like this. Yeah, it doesn't, there's sort of no but if that's at right angles, there would be one line that is perpendicular, and of course I can move it along. Here's another one. There'd be another one up here if I wanted it to be, and so forth. All of those lines are perpendicular to the given line. Every single one of those has slope minus 3 on 2, which of course means if I move across one, that's in lots of 5, but if I move across one, the y value goes down by 1.5. That's our geometric interpretation of slope there. So these all have slope minus 3 on 2. And as you can see, there's a whole family of them. A whole family of parallel lines, in fact. Okay, so our next example says, find the equation of the line passing through a given point, minus 1, 3, and this time it's perpendicular to the line 3x minus 2y plus 7. So our first task is to find the slope of the line we're after. So I'll find the slope of 3x minus 2y plus 7, make the slope satisfy m1, m2 equals minus 1, and then we'll go from there. So I can say here, let's first of all look at the line 3x minus 2y plus 7 is equal to 0. we will write that in gradient intercept form. So that will say 2y is equal to 3x plus 7. So y is equal to 3 on 2x plus 7 on 2. So the slope of this line is 3 on 2. We want a line that's perpendicular to this, so we want a slope such that when I multiply it by 3 on 2, I get minus 1. So I can say perpendicular lines have slope M2 times 3 on 2 has to be minus 1. So M2 has to be minus 2/3. Now I could do as I did last time and just say, look, the line that I'm after is y is equal to mx plus k, and I know m. Or I could use my point gradient formula. So I'll say this. So the required line is, I'm going to go y minus y1, excuse me, is equal to m x minus x1. So in that case, I use my point gradient formula for the line. You don't have to do it that way. I'm just showing you different ways of doing things. And so now I rearrange that, and I get y is equal to minus 2/3 x, that's plus 1, so that'll be minus 2/3, and I bring the 3 over and I have plus 3. So 3 is 9 on 3, 9 on 3 minus 2 on 3 is 7 on 3. So I have y is equal to minus 2/3 x plus 7 on 3. So there is the line that we're after. That's its point gradient form. I could put it in general form if you don't like the fractions. So I guess if I multiply by 3, I would have 2x plus 3y minus 7 is equal to 0. Either of those forms is just fine. And so my next example says, I have two lines written in different forms, but there they are. There's the equation of them. It says, are they parallel? Are they perpendicular? Or, what's probably more likely, is it neither? If I just gave you two lines at random, the most common occurrence is that they're neither perpendicular nor parallel. But anyway, let's have a look. So the first thing to do is to write both of these into gradient intercept form. So if I have x minus y is equal to 3, I can write that as y is equal to x minus 3. And from that, I can see that this thing has a slope. M1 is equal to 1. The other line is already in gradient intercept form, so I can read its slope off straight away. So that tells me that M2 is equal to 2. So we look at that. The slopes are different, so they're not parallel. M1 times M2 is equal to 2, not minus 1, so they're not perpendicular either. So in this case, the answer is it's neither parallel nor perpendicular. So let's write that down. So since M1 is not equal to M2, the lines are not parallel. And I would say since M1 times M2 is not equal to -1, the lines are not perpendicular. And that's our conclusion from there. So without actually drawing anything, we can determine a fair bit about each of these lines.